Thank you. So maybe Paolo, you want Fabio, you want to introduce the guest because
I mean the guests are distinguished scholars. We already introduced Pietro. Riccardo Zecchina is professor of theoretical physics in Bocconi. He is the former director of the Department of Artificial Intelligence and Cognitive Sciences. Computing. You know, in the future you should evolve towards a cognitive as well, so that you encompasses. And then we have Pierluigi Contucci in Bologna. He is one of the leading figures in the debate and in the research. He's also a theoretical physicist.
Mathematician.
He's a mathematician. But
so
he did, I think, then everybody will introduce himself, but he did his thesis with Giorgio Parisi, right? Yes. So it is kind of borderline between the two domains. And then we have Professor Mezard here. He's the former rector of the École Normale Supérieure in Paris. He has a background in theoretical physics, and he is now in Bocconi University. So we put together this panel of...
So we have 3 theoretical physicists, 1 computer scientist, right, an engineer, and 1 economist, more or less.
More or less.
And I should be the philosopher.
Yes.
Good, wonderful. It's going to be fun. So I start?
You start.
Yeah. Okay, so let's presume that I am Ali Raimi and that this is New Rips 2017. And he gets the Test of Time Award for a paper about, I don't remember what, but something very complex. And he goes on the stage and he says, well, machine learning is getting better, we are doing progress, but unfortunately we are still more similar to alchemists than to chemists, because we don't have any theory. We are just trying to do it by hand and make it up as we go on. And my first question is, was Ali Raimi right in 2017? And maybe if he's still right today. So are we getting more theory, more understanding of how these models are learning, or we are just trying by hand and see what happened? And of course, Ali says that alchemy was very good. They made very good things, but they still entertained a couple of wrong beliefs, like, you know, turning into gold. So Marc, maybe you can start.
Okay.
And if we can get the video, that would be very nice. Otherwise, it doesn't matter.
Too late. Let's go ahead.
We go ahead? Okay. Well, maybe more than... actually, probably nowadays, I would say that more than alchemy, I think that what we have entered into is really an era of experimental studies. I mean, the theory is still very much lagging. It's not well understood. There are a lot of people working and some progress here and there, but it's mostly experimental. And so, unfortunately, the careful experiment, and we had a beautiful illustration in Pietro's talk. If you want to study causality, it's extremely costly. And because you cannot just, I mean, correlation is easy. Causality, it's very expensive in time, in compute, in people activity. And so what we have now is a field which has developed into a very experimental field. And there are fundamental theoretical questions which are not answered. And I think that because of that, it faces some problems, the problems of, I mean, we are technically, all this field is based on functions which are interpolating in very large dimensions, basically, and based on examples. And this, it's extremely difficult in that kind of framework to, for instance, to give guarantees. So we have people have invented names for when things go wrong. They say it's hallucination, so you can give an anthropomorphic name just to make people feel at ease with that, but it's just plainly wrong when it hallucinates.
Yeah, and what Ali says in the presentation is that that's fine if we are just tagging pictures in our photo albums, but if we are putting this kind of system inside our health systems or our political system, then maybe we should have sound theories of how they behave.
Yes, first of all, that is certainly true. Secondly, I think that there are even some domains in which it is extremely risky. If you want to make predictions of social nature, like this illustration also again in Pietro's talk, that you want to try to predict in advance whether someone is at risk to commit a crime when you have released this person from prison. I think it is a kind of domain in which one should probably try not to use AI, and maybe not so much to try to use predictions, actually. Predictions in this kind of framework are extremely risky.
You want to jump in? Maybe.
Yeah. So, sure. No, I agree with what... say it again?
No, not sure. We don't see connected. We are still there?
Okay. Well, I'll just say that I agree with what Marc said. And so just to amplify a bit, there is no reason to panic if a certain discipline is in a state of phenomenology and trying to collect evidence one way or another. Well, that's the way it is, and in time, hopefully one gets a theory. The big difference is if you have a theory, you can extrapolate usually a lot from the current state of experiments. You can predict how a system will behave in a different condition, and we are not in that situation right now. And so if a system works, say driving a car that drives down the road and it can detect pedestrians in Torino, there is no guarantee it will detect pedestrians in Los Angeles or Tokyo. And so we need to carry out new experiments. And so it's very difficult to generalize from what we see. And we should be always careful about that. So it's perfectly fine. We are in an experimental state. And we should know that we shouldn't trust the systems outside the envelope of where we tested it. And hopefully one day we will.
Well, from a technical perspective, we are all trying to develop theories. The evolution of AI is so fast that essentially the models and the questions are changing before we have really the time to start studying them seriously. So it's really, I totally agree that it is an empirical science at the moment, and the rate of progress is such that it's very difficult to catch up. I just want to share my anxiety with all the others. And another thing that we should probably mention, and I guess this is what you were saying, is that it's a lot about testing, having protocol to test, because explainability in such complex system is not clear how it can be really reached without a theory, and the theory is lagging behind. So everything is kind of involved. So just like just as we take drugs when we are sick, but we don't have a full explanation of how they work in our body. Well, probably we need to use AI in a very careful manner by testing it in context, so having protocols for it.
So let me make a comment. So the computational engineer says no panic, and the theoretical physics said I'm anxious. I think there is something there.
I'm anxious not for AI. I'm anxious for my work. That's another.
No, I don't know if Pierluigi is connected.
Non lo vediamo
If
più.
he wants to step in. If not, we should try to get him back, because I think he will be. Now, I have three, while we wait for him, I have three footnotes. On the one side, I don't know why, but while Pietro was presenting, an old book came back to my mind, which was Equality, Resemblance, and Order, which was published by a Russian author. The name was, I will come back with the name, but it was published by Mir Publishing. Why? On the one side, we recognize that equality is not part of the real world.
So how do we have...
Schreider,
Come li dobbiamo tenere i microfoni? Vicino alla bocca, okay. Closer to the mouth.
Yes, so this book is Equality, Resemblance, and Order, and I will tell you why it came back to my mind. On the one side, okay, let's forget about equality, and we saw about, a lot about classification and resemblance to different degrees. Then when we move to ordering criteria, we have multiple ordering criteria, and then within each ordering criteria, we have multiple strategies in order to extract the ordering that we want to collect. On the one side, we could classify in hierarchies, so we have golden retrievers and Labradors, which we recognize being dogs. Then we can manipulate similarity, as you have been showing. Then when we move to causality, I mean, what are we really talking about? On the one side, experimental settings for causal pathways have been set up in life sciences, but also in social sciences in order to identify average treatment effects, and there are multiple solutions in order to distinguish the treated from the untreated, and to classify for confounding variables, and so to control for those confounding variables. So to a certain extent, I would like to understand what's really new in terms of the strategies that we are putting together in order to improve our inferential capabilities onto these systems. That's the question number one that I have not only for you, but in general for us. And the second is, the identification of causal pathways comes together with, I don't want to quote Everett and multiple words, but basically comes with a notion of counterfactuals. That means let's try to understand which is the closest possible words that is similar to the one that we are observing, and let's treat one variable at a time in order then to control. So, paradoxically, what we are seeing is, and again, this is perhaps wrong, but we are seeing a methodological convergence across disciplinary fields, because the inferential strategies that we developed, for example, in economics, because of the noisy data that we have been dealing with, are then coming back as a complement to the classification schemes that you introduced. Then we call them biases. Are they really biases? Is it the right term? Because bias, yes, there is a component which is related to biases, but then there is a component which is related to the difficulties that we have in order to control for the right variables and to distinguish, So those were kind of reactions to what you introduced. And yes, that's it. As you see, they are inconclusive considerations. But the inferential machinery that we are mobilizing is basically now determining a convergence between disciplinary fields, and I think this is interesting in terms of the methodology.
Pierluigi, can you see us? Can you hear us? Are you there? Do we have the connection? We don't have the connection.
Great. Okay,
wonderful. We cannot ever the videos. I will not try anymore. Okay, so it's going to get more difficult than 2017 was also the year when attention came out. The attention paper came out in June, the report was in December, and the attention paper was the transformer architecture and everything else. So now my other video was Dario Amodei citing Ilya Sutskever when he says many times, the models just want to learn. So apparently, from some part of the conversation, the public conversation that we have, what happened between 27, what happened after 2022 is...
Pronto.
In 10 seconds, the building will destroy itself. Can you hear us, Pierluigi? So everything that happened between 2017 and today is only more data and more compute and more Moore law. So because the models that want to learn, so we found the architecture that is actually... Sì, ti sentiamo, ma tu non ci senti.
Grazie.
Ok, non ti vediamo.
Ho il video acceso.
Yeah, now we can see you.
Ciao.
Eccoci. Yeah, well, that's the only, the round, then we get Pierluigi again.
So the question is whether...
so what happened between 2017?
Today, has there been a... no, so the techniques, I would say, haven't changed much. Yeah, the techniques haven't changed much. And I think what people have seen is that the capabilities of the algorithms scale almost indefinitely when you add data. And now the question is, how much data do we have? And in some fields there is more data and some less. To me, there is a clear, so first of all, whatever happened is great. We get interesting behaviors, systems that can be used by people to write a letter to their police station or whatever, summarize documents, all of that. So what is there works well. But the learning efficiency is not very good. And so I see that we still have quite a bit of way to go before we have systems that learn as efficiently as humans. And so I see it in the work we do on, say, recognition of plant and animal species, that an expert like a birder can learn to recognize a new species of birds when you show them 3 to 5 pictures of that species. And our algorithms keep being stumped, and they need hundreds of pictures to recognize a new species. They don't learn how to learn in a certain field like humans do. So clearly, there is something we haven't quite figured out in terms of learning efficiency. And then many people, me included, have a feeling that also the reasoning is not there yet. And so these algorithms are very good at splicing together stuff that they regurgitate from these huge data sets. And it feels like intelligence because there is so much there sometimes, like coding or writing. But many of us feel that pure scaling based on data is not the way to go, and there is something more that can be done.
Yeah. Pierluigi, did you get the first part of the conversation?
Yes, I got everything, and I'm very sorry I'm not there with you. I had other commitments, so I am not even at home. I'm in Perugia for a different conference, and I'm very glad to be here, and I want to thank the organizers. Well,
Can you give your view about the lack of theories in machine learning and the progress in the last 7, 8 years?
Of course I can. Well, I heard the comments by Riccardo, by Marc, and also by Professor Perona. They are all very interesting. My personal view on this topic is that we definitely need a lot of theory. I have a way to frame this new revolution with the analogy with the first industrial revolution that I'd like to share with the public, especially. Well, imagine we are back in time with the first industrial revolutions. What happened at that time? Well, let's consider that science at that time was already very powerful. There was classical mechanics that was reached a very nice peak with the work by Lagrange. So it was not only Newtonian mechanics, it was already Lagrangian mechanics at the end of the 18th century, right? In 1780, Lagrange theory was already formed. So everything was mechanical, could be described at the very advanced level. At the same time, there were, let me say, a couple of heuristic parts of physics, of experimental physics, as it's been correctly said, like calorimetry and thermometry. At the end of the 18th century, those were two experimental parts, interesting parts of physics. Well, what happened with the steam engine at the beginning of the first industrial revolution was somehow to put together classical mechanics that was really advanced, together with these 2 or 3 heuristic parts of physics like calorimetry and thermometry. Steam engine emerged from there. Well, you put all that knowledge together, and what you get is a new machine, a machine that produces work out of energy, of some type, energy of some type, but when the steam engines were working, there was no theory able to explain how did they really work. So il motore a vapore, the steam engine, was a heuristic technology that we call nowadays pre-scientific. What do we mean by that? We mean exactly what we are witnessing right now. The steam engine put together parts of science and parts of experimental knowledge and produced a leap ahead that was so long, so fast, that there was no theory at the end of the 18th century able to explain how it worked. In fact, the theory arrived much later, let me say about 40 years later, and that theory is still, as Giovanni Gallavotti often described, the standard bearer of science, which is thermodynamics. Thermodynamics is still in the center of science. Why am I making this comment, historical comment? Because somehow artificial intelligence nowadays has put together many parts of science, like, just to mention a few, electromagnetism, right? Computers work thanks to a theory that has been discovered by Maxwell, which is electromagnetism, and much more than that. They even have quantum components, the transistor, based on semiconductors. Although their behavior is classical, the microelectronics work with quantum mechanics. And then we put all those pieces together, which is classical computation, microelectronics, and we obtain a device that is making a jump so long ahead that we don't know anymore how it works. So it's a bit, the analogy with the first industrial revolution is very strong, I believe. And yes, we made a lot of progresses in the understanding of AI. There are very nice things, especially for shallow networks, and there are improvements, but basically we are still in a very large and profound lack of theory. And for this reason, it's extremely important to cultivate research in this field, putting everybody in, of course, computer science, scientists, mathematicians, physicists. Oh, by the way, just to specify something that has been said, I graduated with Francesco Guerra, not with Giorgio Parisi. I did my PhD thesis with Giovanni Gallavotti, and I collaborated with Giorgio in theory of disordered systems, spin glasses.
Okay, thank you. But so we lack the theory, Marc, that's you, but we are still betting the house on the result of these experiments, because apparently we are investing trillions on training models and that we don't really know how they work, if I understand correctly what you're saying. So we are experimenting with a lot of money, promising great changes to societies, some of them good, some of them probably not, but we don't know exactly why we're doing that. So I find that a bit fascinating. I mean, with the steam engine, it took more time. And
the steam engine took 150 years to be understood, but I mean, it still existed. And I mean, experimental science, there is nothing wrong in experimental science in itself. But as it was said before, as long as you don't have a theory, you don't have guarantees. So if you start to use the device in a very crucial decision, then you can certainly use it as a recommender system, which is then read by someone. But if you want to use it blindly, it becomes a risky situation. So that is the first thing. The second thing for social adoption is that we don't have linked to the lack of theory. We are very weak at explainability of the predictions or the result, and this, it turns out that for the public, it's not a very good thing. I mean, people don't like to have a prediction or something which is based on, I gave the input to the machine, this is the output. We have been trained in having causal reasoning, and so I think this is certainly, and also causal reasoning is very important. It's actually the heart of the scientific method. As when we start to understand the reasoning, we can transpose it, we can have the limitations of where it applies, it does not apply, we can apply it to a new situation. So this is, I think this is a situation, it's from the scientific point of view, it's an extremely exciting moment actually, because, and when you said nothing has, or I don't know, you asked the question, nothing has happened since 2017.
No, what has happened?
What has happened? I mean, I think the main, well, several things have happened, but certainly very big breakthrough in the use of AI for science.
Okay, let's go there.
Chemistry, and LLM. I mean, the language. Who could have predicted that the language production would be as performant? It's irritating. It makes a lot of errors, etc. Still, it is extremely astonishing.
No, I just want to get there. That's the.
May I?
Yeah.
Just so about the analogy with the Industrial Revolution.
You have to
with the Industrial Revolution. We have to think that young kids don't even remember the rise of internet. So let's forget about all this and talk about present times, because it's very difficult to talk with young people with such an historical perspective, because they were born with the internet. So it's really a different field. But so something has happened actually also inside LLMs and inside AI, which connects to what my colleagues were saying, which I think is important. And namely, in order to preserve performance a long time, what the company has to do is to add compute at test time. So instead of just relying on learning from data, an enormous corpus of data, and making prediction, they actually had, in order to keep the performance grow at the same rate, they had to start adding, computation while answering, after learning. So, I mean, you see it when you use ChatGPT, someone thinking about it, and it takes time. Now, what this means is probably that there was a kind of a saturation. So this connects to what Pietro was saying. Probably we don't really believe that LLM can evolve towards a general intelligence as they are. And so in order to, cope with this saturation effect due to size and data, they had to add this compute aspect. So I think something crucial has happened in the last couple of years, signaling that we are facing new problems now, even though apparently performance continues to grow, but behind the scenes, something substantial has been changing. So now I want to be just a little bit provocative. I mean, we face a couple of, alternatives. One is we believe that LLMs are going to evolve, and we are going to invest a lot on them. And if this is the case, then we, as Europe, should invest a lot in it, because otherwise everything will be in the hands just of tech companies in the US and China. The alternative is, well, LLMs are not enough. We need to develop different models, maybe more connected to neuroscience, for instance. I mean, just at least vaguely. So, for instance, what are called world models, that could be an alternative. You have been reading about the new startup by LeCun. So, in this second scenario, we should still invest as Europe in this kind of research. Just to say that in any scenarios, we need to be more active than what we have been in the last, 20 years. And of course, this institute is an attempt in Italy to react to this, but this
so
has
Fabio,
been done
this is you.
General level.
You are the reaction. What kind of a reaction are you? Keep your microphone close to the mouth.
I tried to introduce the topics, and I mean, obviously, I believe that both in terms of scientific interest and relevance and interplay between brute force and theoretical settings across different domains, the second trajectory is more, and in terms of being I would say, too late to compete along the first trajectory. I would say that the second trajectory that Riccardo is envisaging is the most attractive one. But this is both intellectually and in terms of, you know.
Yeah, but to get world model, you still need a lot of compute.
I'm coming to another point, which is the fact that since we are dealing with a variety of functionally independent systems across an incredible variety of domains, the relevance of, I would say, domain-specific theoretical settings is quite important. And the identification of causal pathways goes well beyond prediction along those systems, because it has been said before that our understanding comes through the identification of causal pathways, counterfactuals, what could have been if another element would have interfered with that causal chain. So I think that what we will observe is the fact that AI is somehow raising the bar of our inferential capabilities, but theory is coming back. And I think that theory will come back along somehow the disciplinary, not boundaries, but frameworks that are shaped by the existence of functionally independent systems across different domains.
Pierluigi, what do you think? LLMs are hitting the wall and we need a different architecture, or there is still a lot of juice to get from that?
Well, much more on the second side. In fact, it's a shame that even nowadays we hear on the too often opinion on artificial intelligence as a done technology, as a technology that has been already discovered, like if we are cut out from the European point of view. But as Riccardo already mentioned, AI I believe that AI is a technology that had an impressive breakthrough in the last 15 years, but it's very far away to be done or to be discovered in its entirety. So we have a lot of things to do in theory, and once the theory has been perfected, in applications. It's true that the young people know a little about the Industrial Revolution, but I believe that knowing a bit of history, it's part of the young people duties. So we can say that, we can observe that after thermodynamics, after the discovery of thermodynamics, which was the theory of the Industrial Revolution that arrived 40 years after the development of an industrial technology, not the discovery of the steam engine, because the steam engine comes from pre-Hellenistic times, so it's 1,000 years old at the very, very rough and superficial level. But the industrial technology, to be explicit, able to make money to those who build it, is in 1780. And 40 years were necessary to achieve the theory, thanks to the work of a single researcher, by the way, that was Sadi Carnot. So let's try to be optimistic and imagine how much we can do after a theory has been identified, how much we can save energy to start with, because it's clear that AI is extremely energy hungry. And we know for the interest in energy that all the big tech industry have developed in the last 10 years. We know by the involvement of the Arabic countries that have energy and gas, and they don't want to sell it, they want to use it for artificial intelligence. And we know because of the last talk of Elon Musk and the CEO of NVIDIA, who say we should go in space in doing computation because cooling computers in space costs much less. So we don't know if those are dreams or reality, but it's a fact that the theory of artificial intelligence, a robust theory of artificial intelligence, would solve many, many problems.
Marc, you want to?
Yeah, I wanted to react. Of course, I mean, I am a theorist. I'm dedicating my whole life to trying to build the elements of the theory of AI, so I cannot disagree with all that. But I want to mention that, I mean, we are facing a technological revolution. The theory will come. I mean, we have to work, and theory will come, but we should not let this revolution go in front of us without really taking it very seriously. And I want to bounce back on what Riccardo was saying. I think it is very clear that, I mean, in the last few years, we see a revolution in the capacity of predicting the shape of molecules and having a direct path towards function of molecules, which revolutionize the pharmacy for the future. We have a design of new material is completely revolutionized. Quantum chemistry. We have the language model. It will completely change the way of doing mathematics. That's already taking place. It will happen even more. The language model, very imperfect, etc. Still, we have seen all of a sudden a purely statistical way of generating sentences, which is better than all the research that has been done by all our colleagues, linguists, over many decades.
They are very sad.
So they are very sad, and they
Absolutely.
should be.
I can assure you.
All this, we face it, and we have to get into it, and not only, I mean, we have to think of building the theory, of course, but simultaneously, we have to invest on the technology. And here, I am really trying to push this idea that Europe should be even much more active. This center is one example, but we should have much more of this within Europe.
No, I certainly, on the science side, which is one of the topics that we wanted to raise today, I mean, I have a degree in philosophy and a PhD in linguistics. I spent my life as a generative linguist, so I understand what you're saying. I mean, I feel the pain of having thrown away 25 years of my life and studying something that doesn't really work. Because what happened in linguistics is that at a certain point we discovered that Shannon was right, no? Modern linguistics is born with the discussion between Chomsky and Shannon. Shannon says, with probability you can describe useful property of language, and Chomsky says, absolutely not. And then what happens 70 years later, that with only statistics you can actually describe interesting properties of language, which is bad for linguists. So the same thing is probably happening in many other sciences, which are radically changing. My daughter, second year in biology, she's studying biochemistry with AlphaFold, and that was impossible 3 years ago. A new way of studying the fundamental phenomenon of life. So what other sciences are changing and will change in the next few years? Because one of the promise of the AI is that science will get better. Now, what Demis Hassibis says, solve intelligence and then solve everything else through science. Does it make sense, or again, it's delusional? I'm asking to you.
Okay, thank you. No, okay, so clearly there are lots of applications, and in my university at Caltech, we AI people are 6 people out of 270 professors. We feel pulled in all directions to help our colleagues achieve goals that they think are achievable with AI techniques, which they don't know. And so what we're doing is set up situations where our colleagues can gain confidence in using AI tools and understand what are the pitfalls, what are the techniques that are available. And so a massive work of education is necessary to reap all the benefits. There is no question. What was so you had a question about where
science is going. How is it really science changing so much?
Yeah, so I think that the source of information in science comes from observation and experiment. That's how you validate that what you've done is working. Like if you design a molecule, it's you predicted it would work a certain way, your hit rate may be 20% if you're lucky. Then you have to go to the lab and try out 100 hypotheses to see which one works. So the work in the lab is still has to happen, a connection with the physical world. And I don't think that AI now gives us good automata that work well in the physical world. So their AI is blind and deaf, and so we are the senses of AI. So if you want to paint a picture that is a bit dramatic, is, oh, we end up being the slaves of AI, we just do the footwork. But truly, we use it as a tool, and I can see many ways why humans are still needed in doing all the work. It's an augmentation of our senses at the moment.
No, but I don't think that, the point is not eliminate humans in science, is actually, can we accelerate science with these kind of technologies? So that's one of the crucial questions.
Yeah, it's very clear.
It is.
Yeah.
It's going to happen.
Yeah, and we don't need, in some sense, we don't need explainability, because if we have a black box that predicts molecule structures and empirically it works, then we will use it, right? And so I wanted to go back to one example in medicine on the fact that many areas of human endeavor, we still don't have a theory. So the example comes from personal experience. Take anesthesiologists. If you have a baby or a child going under surgery, they will not let a regular anesthesiologist do anesthesia. They will want to have a pediatrician anesthesiologist. Why? Well, because they know that a regular adult person anesthesiologist doesn't know how to deal with emergencies for babies and for children. And so we have this notion that there is a system, which is an anesthesiologist, who shouldn't be used in the case of pediatric cases. And so we put boundaries around things we don't understand. And so I think society is built with that type of reactions in mind. And so we will, right now, clearly we're very inexperienced with AI, and we don't know all the ways in which we can fit.
Yeah, which is not exactly what we are doing, because there are states that are giving ChatGPT to every single citizen at the moment. They're not putting boundaries. They are just saying full speed ahead.
Yes, but as soon as something bad happens, then people will pay attention.
Okay, so.
And we'll put boundaries in the right way. So we've got to be watchful, like Marc says. And as far as I can tell, society is equipped with mental tools to say this object cannot be used in this condition and it should be used in that. We just need to discover it. And yes, we will discover many of these things the hard way. There will be problems.
Very hard.
We will see problems. So.
I just want an anecdote. A few days ago, a student came to me and asked, it was a course in computer science. I'm teaching the theory part, and then another colleague of mine teaching programming. And he came to me and said, told me, how can I write this Python code without using ChatGPT?
You can't, it's impossible.
So we have to be very careful in how we deploy the technology.
Yeah, but it's true. There are really the state of Iceland decided to give ChatGPT to every single citizen for free. They are paying for that. So they are also writing Python and also recipes and letters to the mother and to the lover and everything else. So these things is inside our lives.
But okay, so let me give you another analogy. So when I was a boy and I learned how to drive, it was inconceivable that you would get a driver license and you wouldn't know how to fix a carburetor. It was like, why? Because when you try to turn a car on during the winter, you've got to know how to use the choke. So you've got to know the principles of an engine. Nowadays, nobody who takes the driver's license knows how the engine works. It's also more complicated, right? So we see things going in both directions. Like for cars in 1950, 1960, we had explainability. We knew why it was making some noise, and now we don't, right? And so it's going back and forth between these situations.
It is fantastic to see how young students, for instance, think in terms of, say, functional blocks. They don't try to go to the microscopic reasons, but really have a different way of thinking. So we will see the effect on science. We will become very clear in the near future. That's a different attitude.
Yeah, I can't get if you are optimistic or optimist or not towards the future. I'm trying to get there, but I can't. You're a pragmatist. Gianluigi.
I'm definitely optimistic. I don't know if by duty or by or by heart. No, I want to add a few things because it has been mentioned mathematics, so it may be interesting to pinpoint how the use of computers has changed in the field of mathematics. So let me mention when is the first time that mathematics had a very visible effect, some very visible contribution by computers. I believe that probably it was 50 years ago with the four-color theorems, right? The fact that a map can be painted with only 4 colors with the constraint that two neighboring regions have different colors, okay? So you only need 4 different pens of different colors and you may paint any possible map. This is a theorem nowadays. It has been proved in 1976 with the help of a computer because the cases in which the theorem could fail were reduced to, let's say, a few thousand, if I remember correctly. And computer at those times, with brute force, checked all those different cases and finally proved the theorem. It made a big impression, that result. But what is happening today is, of course, as we all know, very, very different. So let me give you another 2 couples of examples. Last year, there has been a result in mathematics that, let's say, reached the high-level mathematics, the research done at the highest level. A group of researchers were studying with let's say, AI, and actually I'm saying AI, but it was a very pre-deep learning AI. So it's, if I'm not mistaken, it's principal component analysis. They were studying elliptic functions. So the elliptic functions are one of the favorite toys of algebraic geometers nowadays. Just to mention who uses the theory of elliptic function, Andrew Wiles, to prove the Fermat theorems. Well, playing with this elliptic function, it's very important to study their structure. It's very important to compute their rank. So the rank is a number associated to each one of those functions. Instead, it's a bit more easy to compute what Frobenius coefficients of those functions. Well, this group of researchers found a way to guess the rank with using the Frobenius coefficients, which was already something quite impressive and of which there was no understanding. But at some point last year, this fact came into the attention of Peter Sarnak of Princeton University, one of our colleagues, who I remember said, watching those predictions that machine learning was doing with elliptic function, he simply observed, but if this is true, then there has to be a theorem. And the theorem was almost visible there in those simulations, in those predictions of machine learning. So what happened? I believe it went under-noticed a little bit. But what happened is that Sarnak gave the duty to prove a theorem after watching those screens with a prediction made by AI, gave this problem to one of his students. And these students, in a couple of months, the student is Zubrilina. It's a woman from Russia who was a PhD student in Princeton. And this young lady, proved the theorem in 2 or 3 months. So you see the change of perspective. With the 4-color theorem, it was humans who conjectured the theorem and the computer who proved it with brute force. Now, even with an example as simple as this one, it's the other way around. So in some sense, artificial intelligence is able to make us see guesses and actually to plot the guesses, and humans are proving it in this example that I gave. But in the last few months, Terence Tao and many other researchers are using both computers to prove theorem the old way with formal methods, so logic deductive methods, but also large language model to improve the theorems. Just to make an example, one of the best refined version of the prime number theorem on density of prime numbers has been recovered in a fully automatic way. So let us remember that it was Gauss who conjectured that theorem. So you see, mathematics is, as Marc said, is really going to change profoundly with the contribution of AI. And as such, I cannot be more optimistic than observing a phenomenon that is as interesting as this one.
Wonderful. Fabio, can we talk about a little bit about economics?
What? Because there are many dimensions here.
I'm coming.
Kind of, yeah.
So, funny thing that I find is that we speak about factory of intelligence. We speak about AI factories. We speak about gigafactories. So this 20th century's way of thinking about intelligence as something that can be produced inside a machinery. That sounds strange to me. So why we're doing that? So we need we also need another Marx or Riccardo to describe the new value chain of the AI or post-AI economy.
So on the one side, I don't have the magic bullet on that, so I will focus on a few elements. The first element is the fact that I'll come back to Marx and to
I knew that.
And to Prometheus and to.
I knew that.
But well, we need infrastructures.
The microphone.
We need infrastructures. We need new infrastructure. So the idea of the European Commission to promote these gigafactories network at the European level, I think should be welcome because it goes into the right direction, even if it's, I would say, late and insufficient in terms of the effort. But at least we do recognize that this technological revolution calls for a new infrastructure at the level of the computational capacity. Then we need to design the topology of that. How much should be defined at the level of each member state and how much of it should be coordinated by an effort which is organized at the European level. And this is a proposal that our friends here, together with Giorgio Parisi and Pierluigi and other friends are proposing, right? So to have, even if I don't like the analogy, but something similar to a CERN for AI, implying the fact that these national infrastructural networks should somehow have a coordinating element at the higher level. Coordinating means standards, software engineers, MLOps, means all the attractiveness for human capital coming from different theoretical backgrounds, so it's a complex notion. So first of all, I think that we are observing an evolution of our infrastructures, taking into consideration the fact that I do like the analogy that Pierluigi is making, especially because we are in the Officine Grandi Riparazioni. So we are forced to go back and forth and to play with time, right?
Yeah.
So that
we are also in Torino, you know, the factories, the cars.
Today we had the announcement of the new hybrid 500 in Mirafiori, which is
another announcement.
But at least they are hiring. So there is one important element here, which is the fact that we should enter into the nuts and bolts of these production functions and realize that the electric energy was sustained by turbines, and now we have GPUs, and so GPUs are part of the new industrial. This is issue number one. Nothing surprising, it has to be done, it has to evolve, it will evolve, and then we have all the problems related to natural monopolies, network externalities, and so
which are nice. Huh?
There is a huge issue there to how to regulate and how to have Europe playing a
taxation.
role. And then there is a second element which I want to emphasize that I think is somehow coherent with the branching that I was implicitly alluding to when I was calling back the role of theories in different domains, which is also true in industrial settings. First, I want to mention a colleague, a friend and co-author, Gene Stanley. We wrote a few papers on one specific problem, which is to account for non-regularities in the growth of firms, countries, and sectors. And to make a long story short, our societies do not know growth if not through the arrival of novelty and through Schumpeterian competition, meaning through substitution, meaning that the old goes away and the new takes the lead. And this is what we are observing. So I will say that Aguillon is right, that Phelps is right, and that what we are observing is the new infrastructure for a new flourishing. So coming back to Marx, I do not see the Grundrisse and the labor becoming an addendum to capital, but I do see, on the contrary, freedom. Obviously, there is an issue, and then I'll stop, which is the governance of this process by our democratic society. So there is a meta level which has to do with the way in which we will manage the evolution of our institutional settings. But the technology is not bad per se, is not inducing capital dominating, so it's not instantiating what Marx has predicted in the Grundrisse. On the contrary, there is the other Prometheic component in it, and I'm quite in favor of that. Sorry, I was too long.
No, but keep going. That's good.
I just wanted to ask you actually something, some precision, because it seems to me that there are two relatively new aspects in what is taking place in this new technology. One is the pace, the acceleration. I don't think we have ever seen such a technological revolution on such a pace. It's a pace such that the society as a whole, the workers, the administration, whatever, the regulators, nobody is able to adapt to even the researchers probably. We are not able to adapt to the rhythm. It's absolutely incredible. And this puts some pressure. I mean, we have already seen technological revolution, but how to adapt the society to such thing. And the second question I wanted to ask you is, it is also a case in which it seems that the progress is largely due to the availability. One of the limitations to the progress is the availability of very large amount of data. So it is really the hyper-capitalistic system par excellence that we need. We need to have the biggest company in order to have access to, and in particular, if it has social network, etc., it helps, in order to have access to the largest amount of data in order to build the best systems.
Exactly.
So these are two feedback things that I think make a small distinction with previous.
No, it is not a small distinction. On the second part of the story, for sure, regulation is key. And we can complement what you said, because there is a paradox that you have, for example, national health systems controlled and run by the states, which are not using their own data. So there is a paradox of the monopolistic actor being the state, not using the data to the same extent to which the private monopolists are using them. This is issue number one. For sure, there are huge network externalities here, and there are two-sided markets. And so the issues and the challenges for antitrust and for regulation are there. And you are perfectly right in saying that there is a market power issue that comes to an extent that is unknown in terms of even the recent history. If you take the last quarterly report by Google, you will see that the EBITDA, which is kind of a crude proxy for the profitability of the company, corresponds to $800,000 per employee, which is amazing. because it says that the margins are something that we never saw. And the cash that was generated in the quarter is well beyond the size of public.
No, this is completely out of the world.
This is a completely scale that you're perfectly right. It is unknown in terms of. And as far as the speed is concerned, I agree with some preparation, which comes from 5G and edge computing, and the fact that the mobile phones are also part of this computational effort, and the fact that somehow the annotated data that you were referring to were part of the game since a while. So the speed is enormous, but there has been some preparation in terms of the distributed intelligence that can sustain it. So I'm not saying that the transition will be smooth. I'm saying that there are some elements that induced some optimism on this second question.
It's 5:20, so we can. I have a philosophical question. Can we end with the philosophical question?
Yeah. Riccardo will answer.
Riccardo will answer. So,
as far as we don't have any answer, that's fine.
Well, it's a philosophical answer. It doesn't matter. So another thing that Ilya Sutskever always says is that when transformer learns, they actually observe tokens. They learn from tokens, but what they're really learning is the process that create the tokens. So in a very confused way, it seems that he's trying to say that he solved the grounding problem. So he says that if a model learns about the world, it's because learning from language, it actually learns from the process that caused that language to exist. So it learned about the world, which philosophically is a bit shaky. Any philosophical tradition you get, but apparently is what he thinks is true. And maybe it is true, because of course the models know about the world. So how can the model know about the world if you've never seen the world? There is no embodiment, there is no perception, there is nothing there. There's only language. And language, as far as we know, is not grounded in the world. We call tables tables, but we just call them tables. We could call them something else, and the word table has nothing to do with the table. The grounding, the origin of meaning is one of those philosophical problems that you cannot solve. But the models, they actually know about the world. So that's my philosophical question. What do you think about that?
I have an opinion, but I think Pietro has a stronger opinion. You have been doing much more kind of experiment and studies than me, so I don't know whether...
So where the models get their meanings?
No, I don't know. My view is that they learn correlations about measurables, and the world is out there, and so there may be things that don't get measured, and the models don't know about them, and they don't know about cause and effects, at least unless we talk about them, and the models can read what we write. So I don't.
Yeah, but the second order step that makes Ilya is saying, in fact, since we are talking about that, and since we know what they mean, because we have intentionality, we know what causality is, we humans, then the models learn the second order learning, and they learn exactly the same thing that is out there, which I think is a bit crazy, but
again, is mediated through human experience, which is itself a little bit blind about many things. I don't know, Riccardo.
Well, okay, I'll try to say a few things about it. So first of all, you take language, so tokens, and you project it in a very high dimensional space. This is the first step. So each word goes into a space of 15,000 dimensions. So yeah. to each token, you associate a string of 50,000 numbers. And on top of this, you also associate the positioning within a sentence. This is the internal first representation, and this is learned. Second, you make operation with these strings, such that at the end, you obtain an internal representation that depends on the initial position of the token inside the sentence. And what is interesting is that everything has been, is represented as vectors in a very high dimensional space on which you can make mathematical operations. You can, kind of sum up sentences or something like that.
Yeah, you compress.
So, this is roughly speaking, very roughly speaking, how a transformer and attention mechanism work. So first of all, high dimension, then correlations and positioning, and then making operation which give to the same token different internal representation depending on the context. Then this, of course, the fact that it depends on the context means that somehow they reflect the content of the sentence, so they learn something about the model behind it. So it's true that if you observe some certain experiment, the answer to certain prompts across, say, a long time, coming from language model, you see clearly an improvement in understanding some basic, say, physics of the underlying model, some very, very elementary stuff. But it's also true that as far as the external world is concerned, they don't work so well. And in fact, we were talking about this morning. I mean, the robotics is really still in its infancy. So there are clearly some limitation about how you present the world through text. Okay, so
no, I agree.
Both things are kind of are true. Just what we should maybe. Sorry,
Pierluigi.
Yeah, your philosophical question is very deep and it's very interesting. I like it a lot. Going back to the field that I probably have something a bit more to say respect to what has been said, mathematics. Well. It's large language models now are used not only with natural languages, right? What is being done right now by AlphaEvolve, for instance, one of these AI systems that uses large language model is exactly to take, say, phrases, but not phrases that make sense in the natural language sense. Phrases that make sense in some programming languages that is solving some sort of mathematical problem. So your question, I would like to answer like this. Where does meaning come from in those languages? Let me say synthetic language that do not talk about us. They talk about math, and math is not science in a strict sense. Math is the language of science, and the answer is there is no answer. It's the old question raised many years ago that the efficiency of mathematics in getting meaning for us is by some large extent unreasonable. It is unreasonable how well mathematics, the language of mathematics, carries meaning with itself. Meaning, what do I mean by that? It's able to talk about nature. Okay, so Maxwell equations talk about nations, and they are purely mathematical objects. Now, I'd like to conclude this comment by saying that AI, who is making great progress, who's helping us making progresses in mathematics, although still far from the human collective level. AI can be even better than one mathematician, but the AI systems together are very far from reaching human level for now. Now, one thing that I want to stress is that AI cannot do science yet. By science meaning, is AI able to discover electromagnetism, for instance? I remember a few years ago, I participated in a roundtable, and I believe there was also Riccardo in the same. Actually, Riccardo was the organizer of this roundtable, and a computer scientist, I will not say who the computer scientist was, said that it already happened, that AI rediscovered electromagnetism. Okay, beside this anecdote, I believe that at best, an opinion like AI is able to do science or rediscover a theory like electromagnetism starting from experimental data, it's really to have misunderstood what AI does, what science is. So AI helps us, but it's very far from doing science in the sense that we know. And a debate like this arrived, is AI able to do science, many years ago, and Fabio knows this debate. It's Herbert Simon and Petroni debate, a very crucial moment of discussion of epistemological nature that happened with respect to the old AI, the logic deductive expert system AI. So it's time to start to think about topics like that. Thank you.
Grazie. Riccardo. Marc, you have a comment?
No, maybe just coming back to your question, I would have a radical answer.
Good.
I would like, I mean, I think that in spite of all the progress that I've been underlying of the AI in recent years and the spectacular things, unexpected, etc., I think that so far AI has nearly not learned anything about the outside world. It has learned something about how we represent the world. So I'm putting the philosophical discussion, I'm putting it back to Plato, if you want, because I think that this is the present situation.
Yeah,
and it does not mean that it is, sorry, it does not mean that it will not maybe happen in the future. But so far, I would go in the same direction Jan LeCun from time to time says the cat that comes here on the stage has a much better representation of the physical world than any of our devices, and that is certainly true.
It kind of begs the question, because how did we get the representation? The problem of meaning is always there. How can we get from the outside world, perception, and the way we talk about that, and the sentences that we use, and how we get from the causality that is out there, and the way we talk about causality. So if we do that, it is possible that a model that only learns from our production, from our outcomes, can also learn the same, even without there's no perception. I don't believe it's possible, but it could be the case. So it's really a question. And it makes even worse the traditional philosophical question of where does meaning come from, which after Plato, nobody actually gave a good answer. And this, maybe Fabio is one.
No, I was thinking about the Schreider book, in which, in addition to generating plausible animals, it was obvious that the combinatorial logic that is somehow inherently connected to the notion of computation was also generating magical animals and implausible words. So, you know, I'm not a philosopher, but for sure there is an implication of AI, which is the embeddedness of our representations onto computational architectures. And so we could say that computation and AI are now part of our science of representation. I'm kind of, in a pragmatic way, I would say that they change. This is why I was saying before that they raised the bar.
Absolutely.
Because basically they changed the toolkit already.
And I think that also, getting on the comment of Pierluigi, mathematics, formal systems are cases where meaning arises from syntax in a way. So we are, again, in the same space of the problem. We are getting meaning from something that's already token and multidimensional representation, operation on vectors and compression and everything, which is all syntax.
But I really believe, and I'm biased, coming back to biases, I'm really biased because I really believe that there is an interesting dimension, which is something that perhaps one day we could discuss with LeCun, hopefully.
Hopefully.
Which is the relationship between his approach on world models and the interplay that is somehow reintroducing between the logical tradition in AI and the neuromorphic or the neural network one. Because basically what Pierluigi was referring to was the ambition of Simon Newell and all the crew to, you know, reproduce in a computational system scientific discovery.
Next time.
And so on and so forth. So, but it's fascinating because basically our difficulty in understanding the way in which representations are built is now, you know, coming back through
the king is naked.
Discussion on AI.
The king is naked, always there. Riccardo.
So I don't know if it's time to conclude it.
It's 7:30. So I think, yeah.
Yes. So unfortunately, AI evolves, you know, without caring too much about the philosophical interpretations. So we have to deal with this. And so I have a question for Pietro. So first of all, thank you very much for coming here today. So we often talk about how should Europe react to the current situation in the sense of how can we be, say, at the forefront of research and compete. I think this in general is good for science, to have multiple actors that produce, say, advanced research. Now, from your experience in the US, in which, more or less the trajectory we have observed is the following. Everything started more or less in 2010 to 12 when, some guys started to insist in using neural network for image recognitions, and since then everything evolved. But clearly already a few years after, probably 1 year after, the big tech companies started to get involved in research and they injected an enormous amount of resources. So the impression I have is that essentially in the US what we have are 5 or 6 CERN of AI. Not really a network of researchers, but rather centers that have huge resources. So my question is it possible to see AI evolving with a network of, say, small labs that maybe are below threshold? This is my worry. You see what I mean? How do you see the evolution of AI in the US? Because you have both. You have the point of view of being an important US scientist. We work also for Amazon, so you have, all possible views. And so what would you do in Europe, let's say, to compete?
It's a question, it's worth thinking about it, but again, I think we're facing the question of causality and explainability at the meta level. What is it that caused research to happen that was consequential, and then tech transfer to happen and products to be designed? And so there's a whole chain of events. People can have opinions, and so we can go through a list. But it's an experiment that happened once, so n equals 1 is not very good for making any inferences. So one thing I see is, first of all, the federal government put an enormous amount of money through various agencies, the Department of Energy, DARPA, the National Science Foundation, the Office of Naval Research, into research in the internet, computing, and later computer vision and languages and so on. Much more than was done by any country in Europe and the European Union. And the way the money was given out was on very competitive basis, so there was an openness to newcomers. Now, another thing you see is that indeed, as you point out, it's not in the US overall what it happened, but it's just 2 or 3 places. So it's like a little bit like a Poisson process with a lamp that is very small. And so it's clear that there was an imbalance in how the funding was distributed. So Europe tries to even things out. I'm guessing that it's not the best way, maybe, but maybe not. And in the US, there is an acceptance or a culture of, so let's celebrate the winner and give them even more resources because they're the winner. And it doesn't work well in Europe. So I think that Europe has to work on a model that is culturally compatible with how Europeans react to these things. And there is, so it's very difficult to say. So in Europe, you can point out to other differences, like it's difficult to start a company for young people. There is a lot of bureaucracy. The market is very small in different countries, and a company that starts in Portugal doesn't have access immediately to the German market. They don't get trusted. They don't get investment there. So that's another thing, which is how do you liberalize or they take away the boundaries that are there for startups to succeed against national champions. So there is that. Very difficult to say. So all of these topics are excellent and they should be discussed. And now the question would be, is there any organization like the one you're starting here that can independently do something that leads the way for other, so that is ostensibly good, that everybody can see that this is the right experiment to try and you should imitate it? And so that's the question you're asking yourselves here, right? What can we do locally that everybody will notice that it's the right thing, and then people follow and can set an example? So that's another thing. In Europe, in the US, universities and research centers, each one of them has a very different personality. I don't know if you noticed that you go to one place or another, and people operate in different ways. And so it's a constant experiment where different things are tried out and the best prosper in some ways. And then people learn from what worked well and try to imitate it. Another thing you see is that apoptosis is a higher rate of death in the US, of research centers. Take Bell Labs doesn't exist any longer, and then after Bell Labs there was IBM Research, and it doesn't exist any longer. And then after that, Microsoft Research, which went through a couple of ups and downs, NEC Research, and then now you see that FAIR, the Facebook AI Research Center, is being shut down basically, and so there is a much higher rate. So things get shut down all the time when they don't work out, and that's another thing that maybe Europe should learn, to kill experiments that don't work. They just starve them out of resources and move
So we
on.
should be more US.
No,
The
I don't know
only way.
if you say the US had more success, and so you say, what is it that they do that we should learn from that make our resources more effectively used and make better people want to be involved and all of that? You have huge disparities in salaries, for example. That's another one, right? And which doesn't work well with European culture. So what do you do?
What do you do, Marc?
Well, I am pushing for this idea that we have called it CERN for AI, not because of the CERN, the big machine, etc., but because it's a success story. It's a success story built just after the war, because at some point the nuclear scientists in Europe were feeling that they were lagging much behind the US, and they built an accelerator which was able to compete at the top world level, in spite of all the difficulties that you mentioned. And so I think it's a good idea. And what I want to mention two things. I think that scale will be important. That is, that we need to go to the European scale in order to reach really a stage where we can get into the competition for developing the most interesting next stage of AI. That's one very important thing. We need to be able to attract or to keep talent, intellectual talent, which is very, very important also. So I think this is the perspective. We are working on it. I hope that we can do it. And I would like to mention a last point, which is that I'm not happy with the main trend, even if I think that it's not the last word, but the main present trend of AI, which is language models, being dominated by the four private companies, more or less on the same scheme, in the same state of the US and one in China. I think that's not safe. It's not good, and there is no, even in the US, there is no institution among the universities or the research center, federal research center, which is able to compete. So we have to work on that also.
So we got to the other philosophical question: competition or cooperation? Perfect. I think we can probably stop here. Flavio disappeared, but
Yeah, he had to go to Rome. Yeah.
okay. So
I think we can
it's
stop
done.
here. Thank you very much for being here. Thank you.